In example 4, we're going to integrate the same function as we did in example 3. In example 3, we did from 0 to 1, and the unbounded section was towards the asymptote at 0. In this case here, we're going to start at the 1 and integrate to the right to infinity. So we end up with an unbounded region to the right-hand side. So if I just shade that in, this area in red is the area that we are going to integrate. And I want you to notice something, that when we look at the areas under the curve from that's unbounded to the left, it kind of squeezes to the asymptote very quickly. Whereas if we take a look at the area to the right, it's kind of going towards 0 very slowly. It's kind of being chopped off. It's not going down steeply. It's kind of going way out here, and there's quite a bit of area under here. Okay, and that is going to show up when we actually evaluate this integral. So again, I have an unbounded region on the right-hand side at infinity, so I need to do this formally with a limit. So I'm going to set this up with a limit. The limit as a approaches infinity, and it's going to go from 1 to the unbounded edge, right-hand edge of a, and that a is going to infinity. And like I did before, I'm just going to use a negative power like this to make it a little bit easier to integrate. Now, the antiderivative is exactly the same as in the previous example. So I'm going to have the limit as a approaches infinity. My antiderivative is exactly the same, so I'm going to end up with dividing by 2/3, which is 3 over 2, and then my exponent is 2/3, and my bounds are going to be from 1 to a this time. I'm going to plug in my bounds to evaluate this limit. So I'm going to plug in my bounds, and then I'm going to evaluate this limit. So I'm going to plug in my bounds. I'm going to bring the 3 over 2 on the outside. I end up with a to the 2/3 minus 1 to the 2/3. Okay, so at this point, I can evaluate this limit. It's going to be infinity to the 2/3, which is infinite, minus 1. So now when we evaluate this area, really this area is going to be 3 over 2 times infinity, or it's going to be infinite. This is what we call divergent. Okay, when the area is infinite, we call it divergent. When the area is finite, we call it convergent. So that blue area works out to be 1.5, but this red area is infinite. Okay, both are unbounded in similar ways, but the red area is infinite. And we can kind of understand why, because it is approaching, this is approaching the asymptote of 0 very slowly, where if we take a look at the blue area, it's approaching the asymptote very quickly like that, and it's pinching off that area very quickly. So we have finite area in blue, we have infinite area in red. Okay, so this area to the right-hand side is infinite. And this is a property that we can start looking at. And there are some generalizations we can make about this, and we'll make this generalization a little bit later on. So let's take a look at another example here. This is fairly similar, except it's kind of the opposite way around. So notice that 1 over x cubed is just kind of like the flipping those two areas around. Okay, in fact, it essentially is the same thing if we flip those areas around. But we'll do this from this x cubed perspective. So this area from 0 to 1, okay, it looks like it's not being pinched off very quickly at the asymptote, so this area is probably going to be quite large. And so let's integrate this to see what that area is. So I'm going to approach that asymptote from this side, okay, from the right-hand side. So I need to set up my limit as a one-sided limit as a approaches 0 from the positive side, and it's going to be from my lower bound is a to 1 and x to the negative 3 dx. I can integrate this. I can find the antiderivative. So I'm going to increase the power by 1 and divide by that power. And I have my bounds at a, which is going to go to 0 to 1. So factoring out that negative 1/2, so the limit as a approaches 0 from the positive side, and this is going to be 1 over x squared. I'm going to skip a step here. I'm just going to plug in my bounds here. So 1 over x squared, my upper bound is 1. My lower bound is a, so 1 over a squared, like that. So there's negative 1/2. When I evaluate this limit, I'm going to end up with 1 minus, well, it's going to be 1 over, since it's squared, it's going to be positive anyways, but we're going to approach 0 from the positive side. That's going to be positive infinity. So I get negative 1/2, 1 minus infinity. That's negative infinity. Well, negative half of negative infinity, we just do the signs. It's going to be positive, so we're going to end up with positive infinity. So this unbounded area is infinite. And if we take a look at the diagram, it looks like on the right edge of that blue line, it's probably going to be finite, looking, just kind of guessing at that. So let's test that. So it's infinite on the right side, finite, and we're guessing that's, infinite on the left side in blue, and we're going to kind of guess that this is going to be finite on the right side, and I'm going to shade that area in red here. Okay, so let's test this out. We're going to do the same thing, but you just change the bounds. We're going to have the limit as a approaches infinity of the integral from 1 to a, x to the negative 3 dx. Okay, so this is going to be the exact same antiderivative, limit as a approaches infinity. We're going to factor out the negative 1/2 like we did before, and we're going to end up with x 1 over x squared, and we're going to use these bounds of 1 to a. Okay, so I'm just going to plug in my values. I'm going to evaluate this limit. So I end up with 1 over infinity squared minus 1 over 1 squared. And then evaluating this, well, 1 divided by infinity squared is 0. So I'm going to end up with negative 1/2, 0 minus 1. Negative 1 times negative 1/2 gives me positive 1/2 units squared as my area. So that area to the right-hand side here, this area is 1/2 units squared. Okay, so that then confirms what we kind of were seeing before, was on the left of that line, it's the unbounded area is infinite. To the right of that line, that unbounded area is finite. And we kind of saw the same thing here. On the left, the blue area was finite, and the right area in red was infinite. So if it's finite on one side, it seems to be infinite on the other side. And that's generally true, but there is an exception to this, and we'll go over that exception in a bit.